In this video segment, you guys, just want to talk about reaction rates. This whole unit has been about reactions. We talked about types of reactions, talked about how to balance reactions. We talked about endo and exothermic reactions, meaning some reactions give off heat, some absorb heat. And now we want to talk about the fact that sometimes we want to adjust the rate of a reaction. We want to make it go faster or slower. And I like the picture here, these glow sticks. Many of you have used those glow sticks before. And if you think about those, it's kind of like, in a way, they're kind of like those portable ice packs. The portable ice packs, it's a bag within a bag. Well, these glow sticks, well, it's a kind of a vial within a vial. And for those of you that have used them, you know that as soon as you bend those glow sticks, that vial inside cracks, and then the liquids inside mix with each other, and then a reaction entails, and then that reaction gives off that light. And so the cool thing about the glow sticks is, while that reaction is occurring, they're giving off light. But this idea of reaction rate, how long will the reaction of my glow sticks keep going? And most of the time when you buy the glow sticks, there's a little part on the package that says, you know, maybe they last for 6 hours or 8 hours or whatever the case may be. What that means is that's how long the reaction lasts, because once the reaction's over, the glowing stops. So really what you're wearing in those glow sticks, you're just wearing a chemical reaction. And that reaction takes some amount of time. And that's what we're looking at with reaction rate. So glow sticks, how does temperature affect a reaction rate? Take a look at the picture here. Notice how brightly the glow stick is shining, glowing in the warm water versus the cold water. Well, if we warm up a reaction, it moves faster. If we slow the reaction down, it goes slower. Some of you with glow sticks maybe know that if you put them in the freezer, they last a little longer. Well, when you put them in the freezer, lower temperatures slow down a reaction, so the reaction doesn't occur as fast. Will the glow sticks last forever if you keep them in the freezer? Goodness, no. But they will last longer. If you put your glow sticks in warm water, they're going to go a whole lot faster. So I'm not sure why you'd put them in warm water, because they would disappear a whole lot faster. Milk, can anyone think of why it's stored in the refrigerator? I'll put the answer up in just a second. Anybody think of that? I'll pause. You guys pause the video, see if someone can figure out why we store the milk in the refrigerator. Why do we keep it in the fridge? So keeping it cold slows that molding or rotting process, whatever you want to call it. That milk starts to break down and get kind of gross. And so if we put it in the fridge, just like all of our other foods, if we leave them in there too long, they're eventually going to go bad. But by putting them in the fridge and lowering that temperature, they stay good for a whole lot longer. If you left your milk out on the counter, it would stay good for a while, but nowhere near as long. It's just because of the temperature's warmer. Surface area, how much surface area is exposed to the reactants. And so here, this would be a piece of hard candy. And so think of that Jolly Rancher type candy, you put it in your mouth, and in your mouth it sits in there, and your tongue dissolves it over time. It takes a while, but then once you bite it into pieces, it dissolves a whole lot faster, and that's because of the surface area. Over here, there's more surface area. Over here, less surface area means it's slower. So how much surface area is there? Stirring, if you've ever made Kool-Aid, pretty simple. Dump your sugar in the bottom, and if you leave it there all by itself, eventually it is going to mix. You and I are generally too impatient for that, so we get a spoon out and we stir it. You know, once we stir it, those particles interact and they just dissolve a whole lot faster. So stirring speeds up a reaction as well. So stirring increases. Concentration. With this one, concentration, I usually bring up something that gets diluted. Sometimes you go to the restaurant and they put ice in your pop. As that ice melts, starts to get kind of watered down. The concentration isn't as strong. If you've ever made Kool-Aid and maybe you added too much water, it affects the flavor because it's not the right concentration. That's where we look at these pictures right here. The dark ones would be a really high concentration. This light one would be a really low concentration. And so more reactants cause a higher rate. Lower reactants cause a lower rate. And last one's catalysts. We'll talk about these with biology next year, or those of you that were in biology last year, we talked about those last year. Catalysts are substances that they're naturally occurring in our bodies and they speed up chemical reactions. In our bodies, they speed up reactions hundreds and thousands of times faster, which is crazy to think about it. In our bodies, oftentimes the reactions are just too slow that if we left them to their own speed, we just wouldn't be able to survive. And so our body uses catalysts to speed up chemical reactions. And they just makes reactions go a crazy amount faster. So those are the 5 things that we can do to really play with the rate of a reaction. We can adjust the temperature. Increasing the temperature speeds it up. Decreasing it slows it down. Surface area, opposite. Decrease the surface area slows it down. Increase the surface area speeds it up. Stirring increases the rate of the reaction. Not stirring will slow it down. High amount of reactants causes the reaction to go faster. Low amount of reactants causes it to go slower. And use of a catalyst will always speed up a reaction.